Hello everyone, welcome to Chemical Engineering Knowledge lectures. So, in this lecture we will discuss about the thermodynamic polytropic process. So, polytropic process of an ideal gases. Polytropic process of an ideal gases. The general relation for polytropic process is PV to the power n is equal to constant. This is the polytropic relation. And it is the ideal gas. Ideal gas are those gases which obey the ideal gas equation, which is PV is equal to nRT, where T is temperature of an ideal gas, R is the universal gas constant, N is the number of mole of an ideal gas, V is the volume of ideal gas, P is the pressure of ideal gas. In some cases we can also include the compressibility factor like PV is equal to NZRT. So Z is the compressibility factor. For ideal gas, compressibility factor is equal to 1. For non-ideal gases, it can be greater than 1, it can be less than 1. So it can be less than 1. Now this is the polytropic relation. This equation 1 shows the polytropic relation. Now what is the P? P is the pressure, V is the volume, C is a constant, N is also a constant, and it is nothing but it is the ratio of Cp divided by Cv. Heat capacity at constant pressure, heat capacity at constant volume. The heat capacity at constant pressure can be obtained from the enthalpy relation, delta H divided by delta change in enthalpy with change in temperature at constant pressure. Similarly, the Cv is equal to the change in internal energy with change in temperature at constant volume. So from this relation we can also say that change in enthalpy is equal to Cv delta T. We can also say from this equation that change in internal energy is equal to heat capacity at constant volume and to change in temperature. So this N is for gas like air, the N value is 1.4, it can be 1.2, 1.3, it depends on the gases also. It is N is the characteristic of gas. For different gases the value of N is different. Now come to the polytropic relation, which is PV to the power n is equal to constant. Now the value of n can be 0, the value of n can be 1, it can be positive number, it can be negative, it can be plus minus infinity. So if n is equal to, suppose this is equation number 1. Now if n is equal to 0, then equation number 1 will be written as p to the power 0 is equal to constant, which implies that p is constant. So it is called the pressure is constant. So this process will be called the isobaric process. Isobaric process. Isobaric process is that process in which the pressure is constant. This is the PV graph. So from the PV graph, the pressure constant part will be this. So this is called the isobaric process because the pressure is constant. So this is the isobaric process. Like similarly, this one for this part, the pressure is also constant. So it is called the isobaric path. Now when n is equal to 1, what will be the relation number, what will be this equation number 1? So PV to the power 1 is constant, it implies that PV is equal to constant. So it is called the isothermal process. PV is equal to constant is nothing but Boyle's law. And graphically it can be written as PV is equal to constant. It will be written like this, or this graph. So temperature here is constant and it is called the isothermal process. Isothermal process are those processes in which temperature is constant. Now similarly, when n value is greater than 1 or less than 1, then it will be called the polytropic process. For example, this is the PV. These processes are called polytropic process. These are the polytropic processes. So when n is tend to, similarly when n tend to infinity or when n tend to minus infinity, then the volume of the process will be constant and it will be called the isochoric process. Like this is the V, this is the P. Suppose this is volume at point number 1, volume of system at point number 1 is this, and point number 2 volume is this. So it is called the constant volume process, or it is called the isochoric process. Now suppose this is a PV graph, pressure, volume and pressure, a constant pressure process like this is the isobaric process. Similarly, this is called the isochoric process, constant volume process. This is called the isochoric process. This is point number 1, this is point number 2. From point number 1 to point number 2, the process is Isobaric process. From point number 2 to point number 3, the process is Isochoric process. Volume is constant. Air pressure is constant. From point number 1 to point number 3, the process will be like this. From point number 1 to point number 3 like this, the process will be this black path. The process will be called the isothermal process. The isothermal temperature here is constant, so it is called the isothermal process. Similarly, from point number 1 to point number 4 or point number 5, point number 6, these are called the these are called the 4, 5, 6 process will be called the polytropic process. Polytropic process. So this is the graphical representation of polytropic process. Now what will be the work done during the isobaric process? What will be the work done in the isochoric process? So we will discuss this. As we know that work is equal to P delta V. Now work done from point number 1 to point number 2 will be equal to P dV integral from point number 1 to point number 2. From equation number 1, which is the polytropic process, PVN is equal to constant. At point number 1, this equation number 1 will be given as P1 V1 to the power N is equal to constant. At point number 2, the equation number 1 will be given as P2 V2 to the power N is equal to constant. Suppose this is equation number 2, this is equation number 3. So equation 2 from equation 2 and equation 3 C are equals. So equation 2 can be equal to equation number 3. And equation number 3 and equation 1, 2 and 3 are all equal because C is equal to C in 3 cases. In all the 3 cases. So we can say that P1 V1 to the power N is equal to P2 V2 to the power N is equal to PV to the power N and it is equal to constant. So this is the general relation. Suppose this is equation number 5. Now from PV to the power N is equal to P1 V1 power N is equal to P2 V2 to the power N is equal to PV to the power N is equal to constant C. Now what will be the work done? Work is equal to PdV from point number 1 to point number 2. Now we know that from this equation 4 that PV to the power N is constant. So from this equation 4, we can say that PV to the power N is equal to constant and P can be equal to C divided by V to the power N. So in place of P, we can write C divided by V to the power N in this equation number 5. So from point 1 to point 2, C to the power V to the power N into dV and work done. So this equation number 6 shows us the work done during the polytropic process. Now C is constant, it will be come out from the integral and take the integral from point 1 to point number 2, 1 divided by Vn into dV. Apply the integral, it is C into V minus N from point 1 to point number 2 into dV. So after taking the integral, we will, this is the work. Now after taking the integral, we will get that work is equal to C V to the power N minus 1 plus 1 divided by minus N plus 1 and the limit from point 1 to point number 2. So it will be equal to, that work is equal to C into V minus N plus 1 divided by minus N plus 1 into from 1 to 2 integral. That will be equal to C to the power 1 minus N R 1 minus N R minus N plus 1 are same thing. So equal to V 1 minus N Vn minus 1, V1 minus n, 1 minus n, and applying the limit, that will be equal to 0.2 minus V1 1 minus n. So it will be equal to C1 minus n into V2 1 minus n minus V1 1 minus n, and it will be equal to C V2 1 minus n minus C V1 1 minus 1 and 1 minus n. Now this is called the polytropic work. Now this C is nothing but it is, this C is equal to P1 V1 to the power n, which is equal to P2 V2 to the power n. So in place of this C, we will write this P2 V2. Similarly, in place of this C, we will write this P1 V1 to the power n. So W is equal to P2 V2 to the power n, V2 1 minus n minus P1 V1 to the power n into V1 1 minus n divided by 1 minus n, which is equal to, this work is equal to this minus n minus 1 plus 1. When combined, we will get 1, this n plus 1 minus n, when combined we will get 1. So P2 V2 minus P1 V1 divided by 1 minus n is called the polytropic work. So the polytropic work is nothing but it is P2 V2 minus P1 V1 to the power 1 minus n. And also we know from ideal gas that PV is equal to nRT, or it can be equal to nRT. So P1 V1 is equal to n. If there is constant mole of gas, and also the R is also constant, then it will be equal to RT1 V2 will be equal to nRT2. So suppose this equation number A and this equation number B. Put equation A and B in this equation number C. This equation number, suppose this is equation number C, it will be equal to P2 V2 will be equal to nRT2 and it will be equal to minus nRT1. So similarly this will be equal to minus 1. Similarly, in case of mass, we can write nRT2 minus nRT1 and 1 minus n. N is the mass of gas. N is mole of gas. Number of mole of gas, mass of gas. N is mass of gas. So this is called the polytropic work. Polytropic work. Now, how can we obtain the isothermal work? How can we obtain the isothermal? We can also obtain the isothermal work. Like, suppose from the previous case we know that, PV to the power n is constant. We also know that work is equal to PdV from point 1 to point 2, integral from point 1 to point 2, integral. So we know that P is equal to C to the power n, V to the power n. When n is equal to 1, then the process will be called isothermal work. So from work is equal to integral from point 1 to point 2, in place of P is equal to C to the power C divided by V to the power n. When n is equal to 1, then C divided by V will be equal to P. So in place of P we will write C divided by V, into D, V, and this is called the isothermal work. It can be further simplified like constant convert from integral from point 1 to point 2, 1 divided by V into dV, it will be equal to C ln, because 1 divided by x into dx is equal to ln x. Similarly, 1 divided by v dv will be equal to ln v. So ln v, from take the limit from point 1 to point 2, it will be equal to C ln v2 divided by v1. It will be called the isothermal work. It can be also written as that W is equal to C ln v2 divided by v1, and we know that Pv to the power n is equal to constant, P1 v1 to the power n is equal to P2 v2 to the power n is equal to Pv is equal to constant. When n is equal to 1, then P1 v1 is equal to P2 v2 is equal to Pv is equal to constant. So in place of this C, we can write P1 v1 ln v2 divided by v1. We can also write P2 v2 ln v2 divided by v1. We can also write Pv ln v2 divided by v1. This is the isothermal work. And in place of this V, we can also put Pv is equal to nRT. So V is equal to nRT divided by P. If this is V2, then this will be T2 and this will be P2. So put nRT2 divided by P2 in place of this V. We can also put similarly put V1 is equal to nRT1 divided by P1 in place of V1 in this place. So we can also obtain the relation for the isothermal work. So this was just introduction to isothermal work and polytropic work and isothermal process and other process. So another process which is very important in thermodynamics is called the adiabatic process. So those process in which heat is equal to 0 is called the adiabatic process. So if there is no heat enter to the system, and if there is no heat released from the system, then the process will be called the adiabatic process. So this was just introduction. Thank you very much for your attention. Thank you very much.